Here is what you'll do in this lesson and what you'll be able to do after this lesson. You will be able to calculate the percentage of a quantity using the decimal method. You will be able to express one quantity as a percentage of another. You will be able to calculate the final amount after a percentage increase or a decrease. And finally, you'll be able to solve reverse percentages problems, which means finding the original amount from a given increase or decrease. We will start off with finding the percentage of a quantity. And the method for this is to convert the percentage into a decimal and then multiply by that quantity. If you do not know how to convert percentages into decimals, check the video on the top right on the info card. Let us take a look at an example. Suppose we are told to find 25% of 300 meters. For this, what we will need to do is change that 25% into a decimal. And for that, you just divide by 100. And that will just make it 0.25. Then take that 0.25 and multiply it by 300. And what you'll get here is 75 meters. Therefore, 25% of 300 meters is 75 meters. Next up, you're going to look at expressing one quantity as a percentage of another. For this, the method is to take the first quantity as a fraction of the second. So take the first quantity as a numerator and take the second quantity as your denominator. And after that, multiply the fraction by 100 to have it in percentage. So as a formula, first quantity, which is the part, over the second quantity, which is the whole, times 100%. Let us take an example for this as well. A student scored 67 out of a possible 75 marks. What percentage did he get? For that, you take your first quantity as your numerator, so 67, and your second quantity as your denominator, 75, because this is the whole, this is the entirety of the paper, and this is the part, the amount that you got. Then multiply by 100%. And that gives you 89.3 recurring, which into three significant figures is just 89.3%. We then go into percentage increase and decrease. And the method for this is to use a single multiplier, where the original amount is always 100%. So, for example, if you're looking at an increase of 15%, then since your original amount is 100%, you are increasing 15% to that, which will give you 115%, which in decimals is 1.15 after dividing by 100. And then what you will do is just take that 1.15, that's your single multiplier, and multiply by that original amount. That's how you do percentage increase. Then when looking at percentage decrease, you will take that original amount again, 100%, and you have decreased 8% this time, which gives you 92%, which is just 0.92 in decimals, which is your single multiplier, multiplied by your original amount to get your percentage decrease. Let us take a real example of both. So suppose the salary in 2025 was $16,000 and it increased 10% going into 2026. And we are told to find the salary in 2026. The way we're going to do that is, this is your original amount. and your original amount is always 100%. And what you're doing is increasing 10% to that, which gives you 110%, which in decimals is just 1.1 after dividing by 100. Then that is going to be your single multiplier, and then you multiply by your original amount, which is 16,000, which then gives you $17,600. So that is going to be your percentage increased and the salary in 2026. Finally, the hardest problem type when it comes to percentages, the reverse percentage, meaning you have to find the original. For this, you are given a certain percentage, and from that percentage, you have to find the 100%. And for this, the formula is quite simply the original amount is equal to the given amount divided by the corresponding percentage multiplier of the given amount. Let's take a look at an example where we use this formula. So suppose after a discount of 10%, the price of a TV was $900. What was the original price before discounts? And the formula for that is the original amount, which we're finding, is equal to the given amount, which is $900, divided by the corresponding percentage multiplier of that given amount. So remember, the original amount is 100%, and we got 900 after a 10% discount. So as per the previous section, our percentage multiplier for this 900 was 90%, because we had reduced 10. There was a percentage decrease of 10%. And if the percentage was 90%, then your percentage multiplier was 0.9, because you divide by 100, change it into a decimal. So what you will do here is divide it by that 0.9, and from that we will get $1,000. So that will be your original amount that we found using this formula. If you want to look at it step by step, what you're doing is basically saying that $900 is 90% of the original. How much is 1%? For that, you can divide both by 90. Because if you divide the 90% by 90, you'll get 1%. And that will give you that 1% is equal to 900 divided by 90, which is just $10. So if 1% is $10, then to get 100%, you will multiply by 100. So the percentage then becomes 100%, and your price then becomes $1,000. That's the whole idea of this formula and where this formula comes from. Let us take a look at another example where suppose the selling price of a car is $15,360. This price includes a 28% profit. Then they ask you, what was the buying price or the cost of that car? And if that selling price includes a 28% profit, that means that selling price in percentage is 100% plus the 28% profit, which gives you 128%. So the selling price is corresponding to 128%. And so you want to now find what is that 100%? What was the original price that it was bought for? And using the formula, the original is equal to the given amount, which is 15,360, divided by the corresponding percentage multiplier. The percentage is 128%. The percentage multiplier will then be that divided by 100, changing it into a decimal, which will give you 1.28, which then tells us that the original price, using that formula, is just $12,000.